Yeah, exactly.
You have the old CocoaBot sticker. Do you have like a Swift package manager sticker yet?
No, are there stickers for it?
I don't know. I guess not. Like,
I'll put that one on top of it.
it'd be really expensive. Like they have like it would be like with a bulge.
That's just full of epoxy, so it stays on and it never comes off.
Yeah. Okay, are we ready? Okay. I think we'll start. So yeah, here you can still see like an anti-CocoaBot sticker. Are you enjoying it? No, it's awesome. Like I was just saying, I think when Apple makes the stickers, it's going to be like the battery pack, like the. Yeah. So we continue. We have 4 more talks: 2 lightning talks and 2 regular talks. And the first one is Brian, and he works at Square. He likes dogs. He has a dog. And yeah, and he used to work at VMware. That's all I know about you, really.
Sounds like my sounds like an online dating or LinkedIn profile. This is where the terror is. So, hi everyone. As Chris said, I'm Brian. I'm an iOS developer at Square. I'm here in New York, and I work on the register team. And today I'm going to tell you about a functional programming technique that we've adopted, which we found to be super useful. And I'm going to try and give you some practical examples of it so that you can see about implementing it in your own code bases. So just a quick agenda. I'm going to introduce you to the result type, show you how you can use it with async operations, particularly with HTTP requests. Talk about how you can handle the results of using the result type, using pipelines, and then show you what we do with parsing the results using generics. So by the end, you should have some information that you can take back to your stuff and make it even more functional. But first, what is the result type? Here's a quick overview just so you can follow along. This guy, optional, you're all probably pretty familiar with him. Coming from Objective-C, this was probably one of the largest transitions when you go to Swift, the optional type. We were used to dealing with pointers. You could send messages to nil. Everything was fine. And it created a lot of assumptions in your APIs and conventions around when things could be set, when things couldn't be set. But with optional in Swift, everything got codified. Like you need to handle both cases, or if you don't, then it's made explicitly clear in your code that something's optional, it's there or it's not there. And so this concept that you could have a type that's validated at compile time that represents something or nothing was really important. And so building off that, there's another type, the result type, which provides a similar concept. You could have a type validated at compile time that contains the output of an operation that succeeded or an error describing why an operation failed. Here's a protocol that defines the result type, and as you can see, it can be instantiated with a value or with an error. And like optional, you would typically implement it with an enum, like this. It's just an enum with a success case and a failure case. Pretty simple. But at this point, you might be asking, why? Why would you do this? You just got Swift 2, and like Swift already has error handling built in using do, try, catch. And that's great. Do, try, catch is a good concept, and they brought it over from other languages, and it works a little differently, but it's still great. But the problem with it is it doesn't work very well with async operations and callback blocks. Consider the following callback block signature. You've probably seen ones like this before, either in Cocoa or in code that you've written. There are two optionals, an optional widget and an optional NS error. And by convention, when this block gets called, you would consider the operation a success if the error was nil. I don't know what happened. Oh, it was my software update thing. Sorry about that. It's very critical that I get that updated right now. Do you guys mind? Actually, let's look at Brandon to verify that everything still works. Okay. So yeah, two optionals. If the error is nil, then great, you can go ahead and use the widget. If the error is not nil, then there's an error and you need to handle that. However, what happens if they're both nil? They're both optional. They could both be nil. If that happens, what's the convention? Is it a programmer error? Is it a problem with like a dependency that we're using? Is it a runtime error or something else? So what we can do with this is instead of passing in two optionals, we can use the result type. And I think the completion block and what it's trying to convey becomes much more clear. So here we have the completion block. It's a result, and it contains a widget if it's successful. If it fails, then it contains an error. And when your completion block gets called like this, there's no more ambiguity. You don't have to if-let against both of the optionals to try and figure out what to do. You just have a result, and you can check to see if there's an error and handle the error. And if there isn't an error, then you know it was successful. And you can have functions that return optionals and throw errors with do, try, catch. I think all of us should be making more use of results in our callback blocks. And before going a little further, this is not a talk about monads or telling you what monads are. There are dozens of monad tutorials online and talks. And all you need to know is optional is a monad, and you can map and flat map on it to convert the type of wrapped value. And result is also a monad, so you can map and flat map on it to, if you have a result of foo, you can map it and get a result of bar, or flat map it, and so on. These are what the map and flat map function signatures look like. If you're not familiar with them, talk to your neighbor, because they probably do. You're at a functional programming conference. So with that understanding of the result type in mind, let's go and talk about how we can use result with HTTP requests. So when you have a typical network request, you probably have a method like this: execute request, takes a request, and inside it's going to call into NSURL session, and it's going to have this god-awful completion handler that has a data, a response, and an error. And in this completion handler, you need to do things like handle the error, and then parse the HTTP response to make sure that you got a successful response, and then verify that your data is okay before finally calling the completion block. The problem with this, and it leaks out to your callers, is this line here, the completion handler that's coming from NSURL session, has three optionals in it. An NS data, an NS URL request, and an NS error. And so we need to handle all those scenarios. We do, as I just showed you. But even doing this, you can see in the completion block that we call out to, we have two more optionals. We have the data that we send back in the case of a success, and we have an error that comes back in the case of a failure. And this is leaking out into our callers, and it really, really drives me nuts. So building off what we know about the result type, we can change execute request to take a completion block that has a result of NS data, and then in all the places where we call the completion block, we either create a result with an error or with the actual success value down at the bottom there. And this is great because we've removed the ambiguity from our callers, and the compiler is going to ensure that the result either has the data or an error. So now we can have a method like this, fetch latest widget, that calls through to our execute request function that's already taken care of most of the error handling from the network. And we can handle the result like this. It's just a switch statement, and we go through the two cases. If there's a failure, we call our completion block with a failure, because our completion block, going back, here is a result with a widget as opposed to a result with an NS data. And then if the HTTP request came back with a result containing data, then we just create a new widget with that data and call our completion block with another result that's successful with the widget. But we can take this even further, and as I mentioned, result is a monad, so you can use map. So you can take the HTTP result and map it using this small block here to instantiate a widget using the data. And then you get a new result, you can pass that right into your completion block. It's much smaller, you don't need to add the switch statement every time, map, and the data is transformed. And the great thing is, if there's a failure in the HTTP result, that just carries through. Your result with a widget in it actually is an instance of a result with a widget in it, but there's no widget. There's just the error that passed right on through. So it's much more concise. You save a couple of lines, and this is a good start. So now that we've converted our HTTP request handling to use result, let's consider a more complicated use case. In the previous case, we instantiate a widget from the NS data, but it's not always that simple. We may need to do more parsing or validation of the data in order to create the widget. So in the previous example, we're back, we have the switch statement, we're still passing the failure case through, but in our success case, we need to do more work. We need to parse the JSON from the data, we need to instantiate the widget from the JSON, the parsed JSON, and then we need to call our completion block. And the part that's different this time is that we can't just map it. Parsing JSON can fail, and instantiating the widget can fail. The JSON data could be invalid JSON data, and the parsed JSON could actually be missing fields that are required to instantiate a widget. So we need to handle those errors before calling our completion block. So in order to help with this, we're going to implement two methods, parse JSON data and parse widget JSON, both of which take their appropriate parameter, but they both return results. So parse JSON data returns a result containing an NS dictionary. And so if that fails, if it's invalid data, maybe it's protobuf rather than JSON this time, the result would contain a failure. And so on for parsing the widget. And the thing that's different now is previously we used map to convert from one result with an NS data to another type. But because these things can fail and because these helper methods return results, we can't use map anymore. If we used map, we could end up with a result containing a result containing a result containing a widget. And then that's no good. We want to coalesce those results. And so instead of map, we use flat map. And now we can have a completion handler that looks like this. The HTTP result is flat mapped into a JSON result, that into a widget result, and the widget result is passed to caller. This acts like a pipeline and moves the transform value from one result to another, and the same with the failure. That just keeps moving down the line. We can make this even more concise by just chaining it like this. So one result, flat map, another flat map, and then we store that in a result. And one, as I mentioned, part of this pipelining is that if an operation fails, the error just continues all the way through. To illustrate this, consider this. Say we get back an HTTP result, but the network request got a 500 error. when we call the completion block, that's the error that's going to be passed to our caller. The two parse methods called through flatmap effectively are no-ops. They are not going to get called. And same thing with the JSON error here. If the HTTP result was fine, but JSON parsing failed, it's the JSON error that will pass through the caller. So by converting the result handler to use pipelining like this, we can achieve several benefits. First, it encourages single-use functions for localizing the data transformations and parsing, rather than trying to mix multiple operations in one place in that execute request completion block. These functions are smaller and easier to read because the data flow is outlined entirely in one place. And the code becomes much more testable. You have these small methods, you can feed in test data and verify that you get the result that you want, rather than building up a whole HTTP request, mocking out a response, and then hoping that you get the correct value out of it. So with these techniques in our pocket, I'm going to tell you about how we've started using this technique with generics in order to parse our responses from our network APIs. At Square, all of our network APIs use protocol buffers. So we have a clear definition of our request and response formats as our APIs evolve over time. And if you're not familiar with protocol buffers, it's just a wire protocol. It's analogous to JSON. It's just more defined with a schema. But we generate bindings from the protocol buffers. And so they start to look like this. We have a base protocol, PB message type, that just provides us an initializer that takes an NS data. Then we have request and response messages. In this case, complete bill is a operation that we perform when we are finishing up a buyer's transaction. And then as part of the response, there's a status field. And typically when we get a response back from one of our APIs, we go straight to the status field. We want to see if it was successful. If it was not successful, we dig into the status and generate an error from that so that we can present it to the user. However, the complete bill response is just one of many responses. We have dozens of other API calls that have request to response pairs. And so we don't want to write an individual parsing method just for every single one of those. And so to prevent writing duplicate code, we're going to use generics in order to parse it. And now I'm going to walk you through how we were able to accomplish this. So we start off with the function signature that we wanted. Parse proto response data. It's generic to a type T. It takes an NS data and it returns a result with a type T. And then within it, we instantiate an object using the data of type T. And then we dig into that object to see if it was a success. If it was, we create a result and then return it. If it failed, we create another result and return that. But if you've used generics before, you know this doesn't work out of the box because not all types T have an initializer that takes in NS data. So we need to constrain ourselves to the message protocol that we defined earlier. And that's easy. We just put that right in the function signature. But this still doesn't work because not all PB message types have a status field on them. And so we need to do more to limit our inputs. In order to do this, we create another protocol, PB response message type, that has a status field. And then we just make all of our response types that have a status field in them conform to this protocol. It's really easy. They already have the field, so they already conform to the protocol. You're just making it explicit. And then we go back to our parse method and change the way that we're constraining the type T. We specify our new protocol. And now you may be thinking, we did it. That's it. It works. But it still doesn't work. It's a little obvious and a little surprising because it looks like it should. If you compile this, the compiler doesn't know what kind of binding to parse the data into. It knows T has to be of this particular type with these particular rules, but it doesn't know which concrete instance of T that it needs to instantiate. So instead, we need to give the compiler a hint, and we do this. So when we're defining our local variable that we're going to store the result in, we specify it's a result with a complete bill response. And so by giving the compiler this hint, the compiler is able to work backwards, identify that the result is going to contain this type, and the result of this function has a generic type, so the generic type must be this type here. And so back in our parse function, that's where that's how t gets decided to get used. So we can have a completion block, have a network API like this, complete build, that calls through to execute request again, gets an HTTP result, and then create our little hint for the compiler, flat map using our, and then we can map another value out of the bill to create out of the response in order to create another result. And then finally, we can call through to our completion block with the result that we want. By adding the hint to the compiler, you can see that we lose a little bit of the conciseness that we had earlier with all those nice little flat maps in a row. But the pipelining still works as expected. There's a failure, carries right on through, and if there's no failure, it keeps transforming the data until you get what you want. We found this to be very useful. It's prevented a lot of duplicate code, and hopefully you can get something out of it as well. So in summary, just finishing up, like optional, result makes your code much more concise and easier to reason about by moving extraneous code off to the side and into smaller functions. The pipelining that it enables allows for chaining transformations of results while carrying through any failures that occur. This reduces additional error handling code that you might have sprinkled throughout your completion blocks. And finally, by providing a couple hints to the compiler, you can make parsing all of your custom data types work really well and generically, and that's been super powerful for us. For reference, last year at this conference, John Gallagher gave a talk about networking with monads. I'd recommend checking out that talk if you want to know more about the result type. And also, this is an anti-typical result, is a typical, not typical, it's a popular implementation of result that's available on GitHub. That's all for me. I'm around for questions, and thank you.
Can you talk a little bit about the interaction of the result type with the Swift throws support that was added in Swift 2? Like, and specifically, how you have like bridges between functions that throw and functions that return in result type back and forth, or haven't really needed it?
So far, we haven't really needed it. However, the result type that's fine as its error field is actually of error type, so it's possible for the person, the code that receives the result, to inspect the error field, and there it is. There it is. So when it's initialized with an error, it has an error type. So because error type is the protocol for objects that are throwable, you could theoretically just throw the error field from the result. But it's also possible to do bridging if you needed to.
So one thing I liked about the result type is when I used it, I also could generically define the type of the error. So you can actually constrain the error type. But then I ran into a problem when I had a similar approach like this one. When you have chain functions, then the first one will retain an HTTP error, the second one will retain a parse error. So did you ever look into if you have a way of retaining that error information, not erasing it using error type, or that's the question.
That's a good question. So result type here can be implemented two ways, right? Right now, it's only generic over the value field, but it could also be generic over the error field. I've gone with this implementation because error type's just a nice general protocol to have for any error. And so if you make all the errors that in your application that can occur from something conform to error type, then it's fine. That will pass through, right? Because it's just conforming to the protocol. If you make it generic across the error field as well, then you kind of potentially have chaining of methods that are of different types.
The question is then, how do you indicate which specific errors you handle? Through documentation, like Apple recommends it for throws, or you have a different?
So typically what I do, actually my implementation of it, we have a handle function that has like on failure that's the closures, and based on that, it'll execute one of the closures based upon the state. And in the on failure, I just add a bunch of if-lets. If it's this type, if it's an HTTP error, if it's an NS error, if it's some just enum that conforms to error type, it if-lets over that and acts accordingly. But one thing I like about that is it puts all your error handling together in one place, as opposed to sprinkling it throughout. So like rather than handling HTTP errors up here and parse errors down here, puts it all in one place so that way, I don't know, if you have to present an alert to the user or something like that, all in one place.
Okay.